everyone, welcome back to all of you on my YouTube channel. I am Git Misra. I am teaching for GATE chemical aspirants from last 5 years. So here I am coming with revision series of chemical technology that is very important. This lecture will be very crispy and a very small interval of time. In very small time, you will be able to revise the whole syllabus for chemical technology. So first I'll be starting with the petrochemical industry. So here you can see that this I'm just making this video for mostly oriented about the GATE chemical aspirants who are appearing for GATE 2025, right? So I'm requesting you all, those who have not subscribed my channel, please subscribe and hit the bell icon, so that if I'm putting any video on my YouTube channel, definitely you are going to get the notifications from there, right? So without wasting our time, let's start with the topic first. So here once I am talking about the petrochemical industry, so mostly we'll be talking about the chemical compound that is being formed in this particular industry. So I will be mostly oriented about the questions that is being asked in the gate, right? So first I'll be starting with the formaldehyde. Formaldehyde production, right? So mostly whenever the gate used to ask this question, they will ask questions what kind of catalyst is being used, what kind of reaction is happening, and what is the reactant and what is the product. So the production of formaldehyde is happening from CH4, that is methane, and once you oxidize methane in presence of copper zeolite catalyst. So the catalyst here is copper zeolite catalyst, and here after oxidation you will get CH3OH, that is the formaldehyde, right? So here you can see that copper zeolite, or you can see directly it will be written in the form of copper and zinc, right? So here this one is the reactant and this one is the product, and catalyst used is either copper zeolite or copper and zinc, something like that, okay? That is the case. Second reactions or second product that I am going to talk here is chloromethane. Chloromethane. So whenever we are talking about the chloromethane, first we have to understand what is the reactant and product. So this reaction is happening by free radical mechanism that you would have studied in class 12 in organic chemistry. So first what will happen, the methane will come and it will react with the chlorine and it will form CH3Cl, right? That is called as the monochloromethane, and again HCl will get reduced, and after that you can see that CH3Cl will again react with the free radical mechanism and it will form CH2Cl2, dichloromethane plus HCl, and again this dichloromethane CH2Cl, again it will react with Cl2, and all of these reactions is happening this free radical mechanism. It will form chloroform CH Cl3 plus HCl, and again this CHCl3, again it will react with Cl2 and it will form CCl4 plus HCl. So all of these reactions are happening due to the free radical mechanism. First thing. Second thing is that the most important part of the reaction is, this reaction is very exothermic reaction. All of these reactions are exothermic reaction, and this reaction is happening in the gas phase. So sometimes they will ask you what is the phase involved in this particular reaction. So questions on phase has not been asked till now, and this reaction is happening, that is exothermic reaction, means it is being involved in this reaction, right? Now coming to the third compound here, that is the vinyl chloride. So in this petrochemical industry only, you have to understand or concept regarding reactant, product, and what kind of catalyst and what kind of reaction condition is there, and whether the reaction is happening in the gas phase or liquid phase. And the next thing is that endothermic and exothermic reaction, that's it. So when we talk about the vinyl chloride, so it will form from, let's say C2H4 is there, ethylene, it will react with chlorine and in presence of FeCl3. So the catalyst here is FeCl3 and it will form CH2Cl2. Is that clear? CH2Cl2, and this reaction is happening in liquid phase. phase. And again, this reaction is the exothermic reaction, right? So due to this exothermic reaction, you will see there is a delta H amount of heat which is being liberated, and this reaction is happening in the liquid phase, let's say. And after that, you can see that CH2Cl2, it will break in form of chloral, and it will form CH2 CHCl plus again HCl. So this reaction is happening in the gas phase, right? So here you can say that this reaction is happening in the gas phase. So this is the vinyl chloride. So here you can see that two kind of catalyst is being used, FeCl3 and C chloral, right? So vinyl chloride is formed by when C2H4, ethylene is reacting with Cl2, the main reactant is ethylene, and it will form CH2Cl2. After CH2Cl2, since this reaction is exothermic and this is happening in liquid phase, so first reaction is happening in liquid phase, that you need to understand. And when CH2Cl2 is reacting with in presence of chloral, it will form vinyl chloride and HCl gas will get liberated. So I think all of these reactant and product thing, you have to understand which reaction is happening in the exothermic condition, endothermic condition, and what kind of catalyst is being used, right? Now coming to the fourth reaction here, that is very important reaction, and that is the ethylene oxide. So ethylene oxide production is very, very important when I'm talking about the gate. So when we talk about C2H4, that is ethylene, it will get partially oxidized, half O2, and it will form ethylene oxide CH2O CH2. This is ethylene oxide, right? And this reaction is happening in presence of AgO, silver oxide, right, or alumina. So now you can see here that whenever oxidation, because here oxidation is happening, so partial oxidation is happening, and the catalyst is being used here is AgO or alumina, Al2O3, right? So this is very important. You have to remember these things here. That is, sorry, the catalyst used here is AgO or AlCl3, and partial oxidation is happening, right? Okay, now coming to the next, that is ethanol amine. This is also very, very important substance, that is ethanol amine. So here you can see there is amine group, right? So definitely what will happen when CH2O CH2 means ethylene oxide is reacting with ammonia NH3, because ammonia will get converted into amine group in the later period. So here it will form monoethanol amine, that is CH2O CH NH2 plus obviously NH3. Is that clear? And this is called as the monoethanol amine. Monoethanol amine, right? And after that, what will happen? This monoethanol amine will get converted into diethanol amine, and you will see that NH2, it will form NH2 CHCO NH2 plus again NH3, and this reaction is happening, and this this is called as the ethanol amine, and this diethanol amine will get converted into triethanol amine. So here you can see C again NH2 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 and double bond O, sorry, single bond O. So ethanol amine is there, so you can write CHO, right? So this is called as a triethanolamine. So this reaction is not very much important, but again, if you want to produce ethanolamine, then you have to use the reactant is ammonia and ethylene oxide. That is the important thing that you have to remember, right? So in what will be the reactant that is used for the production of ethanolamine? That is the ethylene, obviously, and ammonia. So here you can say ethylene and ammonia, ethylene oxide and ammonia, that will get converted into monoethanolamine, diethanolamine, and triethanolamine, right? Now next reaction is very, very important, and this is isopropanol. So isopropanol production is very very important. You would have studied in class 12. So first, this production requires two steps, that is sulfonation first. So in sulfonation, what happens? Your propylene react with H2SO4 sulfuric acid, and it will get converted into isopropyl sulfate. It will get converted into isopropyl sulfate. Is that clear? Okay. Now, after that, what will happen? After sulfonation, there is a hydration step where isopropyl sulfate react with the water molecule, and it will get converted into your isopropanol plus again H2SO4 will get liberated, and in the next step H2SO4 will be again used here in the first step. So in case of production of isopropanol, what will you see? That propylene will react with H2SO4, it will get converted into isopropyl sulfate, and again isopropyl sulfate react with water molecules, it will get converted into isopropanol, and one more H2SO4 molecules will get liberated. Right. Now coming to the next compound, that is acetone. That is also a similar kind of reaction that will happen. So here you have produced isopropanol. So how you have produced isopropanol? So propylene is reacting with H2SO4, it is producing isopropyl sulfate, and isopropyl sulfate will get hydrated and it will form isopropanol. And then what will happen? Isopropanol will get dehydrogenated, liberate hydrogen in presence of copper molecules, that is reducing is happening. So reduction reaction is happening, and it will produce acetone. So copper work as a reducing agent, right? So whenever you say copper will work as a oxidizing agent and reducing agent. So when we talk about isopropanol, so isopropanol will look like in this way: CH3 and O. So OH, right? So what will happen in presence of copper molecules? What hydrogen molecules will get liberated? So these molecules will get liberated, and here you will see it will form CH3, C double bond O, CH3. So this is called as the acetone. So what is the reactant here? Isopropanol. Hydrogenation, dehydrogenation reaction is happening, and due to this dehydrogenation reaction, what will happen? Acetone is going to get formed, right? So ultimately you will see here that isopropanol will look like in this way, and here you are removing a hydrogen molecules and in presence of copper catalyst, and it will form the acetone, right? Now next reaction, that is also very very important reaction, that is the production of cumene, or we say it as isopropyl benzene, right? So here what will happen? Alkylation of benzene is happening, that's why this is called as isopropyl. So isopropanol group will get added to the benzene. So let's say if you have a benzene molecule, something like that. So again I'll draw. Okay, this one is the benzene molecules. Okay, so benzene will react with propylene. So in presence of zeolite catalyst, benzene will react with propylene in presence of zeolite catalyst, it will produce isopropyl benzene, right? And this one is called as the. So only the main important thing is that the catalyst that is being used over here is the zeolite, right? And the reactant is benzene and propylene. So when propylene is going to react with benzene, so this one is your benzene, right? This is your benzene. So benzene will react with isopropylene in presence of zeolite catalyst, it will form the isopropyl benzene, and this is also called as the cumene. You don't have to get confused here, right? Now coming to the next substance, that is acrylonitrile. This is also very important compound, very frequently get used to ask this question. So this is produced by ammoxidation process. Acrylonitrile. So what is ammoxidation process? Where C3H8 propylene will react with ammonia in presence of oxidation. So ammonia and oxidation, right? That's why ammoxidation process is there. You can say that propylene is going to react with ammonia and oxidation. That's why this process is called as the ammoxidation process. And once it will react in presence of molybdenum and bismuth work as a catalyst here, and it will form acrylonitrile, and a water molecules will get liberated here. Is that clear? So this reaction is very important. How this reaction is happening? When propylene is reacting with ammonia and oxygen, that is called ammoxidation process, it is going to form acrylonitrile in presence of molybdenum and bismuth as a catalyst. Is that clear? Now moving towards the next compound here, 10, and you can see that oxo process, that is very important process. Oxo process. So what is oxo process? So in oxo process, what you will see, this is also called as the hydroformylation reaction. Hydroformylation reaction. So in oxo process, what you will see, this process is used for the production of aldehyde. That is very important reaction. So when we use oxo process, formation of aldehyde, right? Now next is butadiene production. Butadiene is a kind of rubber. So when N-butane is going to get reduced in presence of chromium oxide or alumina, butadiene will be formed, right? N-butane is there, and you are removing the hydrogen molecules in presence of CrO3 and Al2O3. So CrO3 and Al2O3 work as a dehydrogenation agent, and here you can see that there will be a production of butadiene. So N-butane will produce butadiene in presence of catalyst CrO3 and Al2O3. So catalyst that we are using here is CrO3 or Al2O3, chromium oxide, or Al2O3, that is alumina. Now coming to the benzene product, this is very important. Sometimes you can see questions from there. Benzene product. So first, in benzene product, I will be talking about how we can form benzene. So toluene to benzene. So how is it going to form? So if you see, so how does the toluene look like, right? So toluene look like in this way, and if you remove a water molecule, hydrogen in presence of chromia, obviously, so whenever hydrogen is being removed, then you have to use Al2O3 or chromium oxide. So it will form a benzene molecules plus CH4. Is that clear? You are going to add hydrogen. So hydrogenation is happening here, right, in presence of chromia, and you will be getting the benzene and methane gas, and this is called as the toluene. Is that clear? Now next is phenol. So how will we form the phenol? So you have cumene. So cumene is isopropyl benzene, right? So here we have seen that cumene will look like in this way, and if I am supplying air in presence of NaOH, it will form cumene hydroperoxide, and then what happens, cumene hydroperoxide react with H2SO4 molecules, it will form phenol plus acetone. So the chemistry that I am not going to discuss, you would have studied this things in class 12 organic chemistry. But what is the reactant? Reactant here is cumene, and when cumene react with air in presence of NaOH, that is basic medium, it will form cumene hydroperoxide, and again cumene hydroperoxide react with H2O molecules, sorry, H2SO4 molecules in presence of acidic medium H plus, and it will form phenol and acetone. So this reaction is very important. Sometimes they'll ask you the reactant that is being used for phenol production is cumene and air molecules, and when there is basic medium, that is NaOH is used, and when there is acid, then H2SO4 is used. So this reaction is happening in one step is happening in basic condition, and another step is happening in the acidic condition. So base is used as NaOH and acid is used as H2SO4, right? So through which we can form the cumene phenol. So again you can see that how this reaction is happening. If you want to see the structure also, so let's say this one is your cumene, that is methyl group and methyl group, that will be there, and in presence of oxygen molecules and basic medium NaOH will be used. So obviously it will form cumene hydroperoxide C, and then this methyl group will be like that, and here methyl group, and it will form hydroperoxide, right? You can see. Now what will happen again, if you are supplying H2SO4, so due to this particular region, what will happen, this is going to form that OH group will break from here, and it will get added here, and after that you will see that there is a formation of acetone. So this is cumene hydroperoxide, this one is cumene hydroperoxide, and this reaction is happening in presence of base NaOH, and after that H2SO4 will come, and this kind of reactions will happen, electrophilic substitution, some kind of thing that is not very much required here, and it will form, that is called as the phenol, and this is your acetone. Is that clear? Okay, after that I'll be moving towards next, that is oxidation of toluene to form benzoic acid, right? So how we are going to form benzoic acid, that is very important. So benzoic acid, so whenever acid is going to form, definitely there will be some oxidation reaction will be happening. So you have toluene, this is your toluene, right? And cobalt naphthenate will be used as a oxidizing agent, and it will form benzoic acid. This is called as a benzoic acid. So cobalt naphthenate is being used as a catalyst here. So benzoic acid is formed from the toluene while oxidizing the toluene in presence of cobalt naphthenate, and it will form the benzene, or sometimes it and again the benzoic acid will get reduced in presence of LiAlO4, right? And it will form phenol. This phenol will look like in this way, right? So this is the phenol. So this is benzoic acid. From benzoic acid you are forming phenol by using LiAlS4. Dehydrogenation is happening. Is that clear? Okay, so I'll stop this lecture here. Before stopping this lecture, I'll revise first that what I have discussed till now. So here I have started with the formaldehyde. The formaldehyde is going to form from CH4, that is methane, and this is happening in presence of copper or copper zeolite as a catalyst, or copper and zinc, and it will form CH3OH. Then I have discussed about the chloromethane, that is how chloromethane is getting formed, CH3Cl, and after that you can see also we have formed chloroform and carbon tetrachloride. That this reaction is happening in gaseous phase. Exothermic reaction is happening, and free radical reaction, it follows free radical reaction mechanism where CH4 is reacting with Cl2, it forms CH3Cl plus HCl, and again CH3Cl react with Cl2, is form CH2Cl plus HCl, and CH2Cl plus Cl2, it will form CHCl3 plus HCl, and CHCl3 react with Cl2, it will form CCl4 plus HCl. So exothermic reaction is happening in the gases. Now coming to the vinyl chloride, already I have told you that when C2H4 plus Cl2 react, it will, in presence of FeCl3, it will form CH2Cl2, and again CH2Cl3 reacts in presence of chloral, it will form CH2Cl, that is vinyl chloride, and HCl. Now ethylene oxide, this is very important compound for the GATE examination. So ethylene oxide will form by partial oxidation of ethylene plus half O2 in presence of AgO, that is silver oxide or alumina, it will form CH2OCH2. Ethanolamine will form by reacting ammonia with ethylene oxide, and it will form monoethanolamine, diethanolamine, and triethanolamine subsequently in this particular reaction. And isopropanol, it happens in two steps. First, it will start with the sulfonation, where propylene will react with H2SO4, it will form isopropyl sulfate, and isopropyl sulfate will get react with, in presence of H2O, it will form isopropanol. Now acetone, so isopropanol get reduced while removing hydrogen in presence of copper, and it will form acetone. So here you can see that this hydrogen molecule is getting removed and it will form the acetone. So what is the reactant in formation of acetone? That is isopropanol. And what is the catalyst that is being used? Is copper as a catalyst. So let's say if you are forgetting most of the time what is catalyst used in the dehydrogenation, then you can use the copper as a catalyst. Now coming to the cumene or isopropyl benzene. So benzene will react with propylene in presence of zeolite, it will form isopropyl benzene. So this is called as the alkylation reaction. So benzene will react with propylene in presence of zeolite catalyst, it will form isopropyl benzene. And acrylonitrile, so acrylonitrile is being formed by using this ammoxidation reaction. So ammoxidation reaction, already the name itself justify ammonia and oxidation is happening, and acrylonitrile will form from while reaction of C3H4, that is propylene, ammonia, and oxygen, it will form acrylonitrile in presence of molybdenum bismuth as a catalyst. Oxo process is used for aldehyde production, and butadiene will form while using N-butane will get reduced in presence of or dehydrogenation of N-butane produce butadiene, and the catalyst uses CrO3 and Al2O3. Now coming to the benzene product, here how we can produce toluene, benzene from the toluene. So toluene is methyl benzene, and in presence of chromia catalyst, the hydrogenation reaction will happen and it will produce benzene and CH4. Now coming to the phenyl production, so isopropyl benzene, cumene or isopropyl benzene will form the cumene hydroperoxide in presence of oxygen. So here you can see that when isopropyl benzene or cumene will react with water in presence of NaOH, it will form isopropyl benzene, and again cumene hydroperoxide, and cumene hydroperoxide again it will react in presence of H2SO4, it will form phenol and acetone. Now benzoic acid can be produced from toluene, and you can see that in presence of cobalt naphthenate, and again this benzoic acid will get reduced by in presence of LiLH4, and you can form phenol, right? So that ends the discussion of this petrochemicals. In the next lecture I will be talking about some 3 to 4 compound, that is styrene, phthalic anhydride, maleic anhydride, DDT, and oxo process, that is hydroformylation reaction also. So out of this only, if any question is coming out of 1 mark and 2 marks, this will come from here only. Okay, thank you, see you in the next lecture.